guys. So first we're going to go through just a little bit of a review about derivatives. Okay, now this is just the basic ideas. Okay, we talked about in class, reminder that the derivative is the gradient function. It gives us the slope of our original function at any point. Okay, now sometimes we'll look for the derivative at a specific point. If that's the case, we'll actually get a value. We'll get a number representing the slope, like 1/2 up 1/2, right? The slope of the tangent of the derivative at that point. Okay, but in many cases, we just find a function which is representative of the derivative anywhere along that function. Okay, so that's what we're going to do here. Hopefully right here, remember in math studies, all we have to do is we have to know how to find the derivative of a polynomial function. Okay, so a number or a variable to a power. Okay, so we're going to start simple. We're going to find dy dx for each of these four functions. All right, we're going to start with dy dx for y equals 3x squared plus 5x cubed. Now this should be the easiest one. Just a reminder that all we do is we take that power, we multiply it by the number in the front. If there's no number, then the number is just 1, which means it stays the same. So then we just bring that number in front, and then the exponent goes down by 1. Okay, so should be pretty easy. So in this case, I've got the 2, which is going to come down here in front of the 3. So the 2 is going to be multiplied by the 3, which is going to be 6. So I'm going to have 6x, and then the exponent goes down by 1. So x2 minus 1 is 1. 1, of course, is an exponent that doesn't have to be there. And then I'm going to go here also. The exponent is going to be moved in front with the 5, which will give me 3 times 5, which is 15. So I'll have plus, the sign will stay the same unless I have a reason to change it, and subtract 1, which means it will now be x squared. This function is now dy dx. Okay? You don't have to worry too much about why that works or how it works or anything like that. Just understand that if I take the derivative, if I get the derivative function, then what I get is the slope or the gradient function. Okay? Now at this point, I could put a number in for x, and it would actually give me the slope at that specific point for my original graph. This original graph has kind of a weird shape, right? It's cubic, so it's got a couple of bends in there. But I could find the slope anywhere on that bendy curve by using this function here. Okay, now I'm not going to go through that anymore. I just want to make sure that we have the idea of how to deal with each of these situations. All right, so let's move on to the next one. Again, remember, we can only take the derivative. The only derivative property or skill that we've learned so far is dealing with those polynomials, x to a power. So right here, we're okay with most of them, except for the fact that this one has a fraction, and the x is on the bottom. All right? So if the x is on the bottom, then what we need to do is we need to rewrite it so it's not. Okay? Rewrite it so it's a polynomial. So first thing I'm going to do is I'm going to rewrite this. This is not the derivative function. This is still the same function, 7 minus 4x. Plus, what I'm going to do, remember, with a positive exponent, I can rewrite it as a negative exponent and move it up to the top. So the 5/2, the 5/2 isn't changing. That 5/2, I didn't do anything to it. All I'm doing anything to is that x to the second power, which is now going to be on the top, or no longer on the denominator, which means that it's x to the -2, just like what I have here. So at this point, it's now in more or less a polynomial style form, and I can take the derivative. So remember, you may remember, so now I'm actually going to go dy dx, you may remember that the derivative of a constant is 0. Reason for that is because if the value is always 7, then the slope is 0. It's a flat line. So derivative of 7 is 0. Here, I'm going to have, this is x to the first power, so I'm going to bring the 1 in front. 1 times, I like to treat this whole thing as -4. You can do it however you want, but I'm going to go 1 times -4, which is still going to be -4. And then the x to the first power, that goes down 1, remember, from 1 to 0. And x to the 0 power is 1. So -4 times 1 is going to stay the same. And then I will have plus here, the -2 is going to come in the front. So that will give me a -10/2. And then it will be x to the, subtract 1, minus -2 minus 1 is -3rd. Now, to simplify this, and really I should simplify it whether I want to or not, I should reduce that fraction. I should get rid of the 0. And so my final answer here is probably going to look like dy dx equals -4 minus 5x to the -3. If you want to put the x to the negative 3 on the bottom, then go ahead, be my guest, move it down to the bottom. Haha, where did I go? I'm right here. Okay, well, let's go on with the next question, okay? So we got the idea on that one, we got our derivative, let's move on to the next one. Okay, so again, remember we want to get it in that polynomial format. If it's not in that polynomial format, then it's not going to work. Okay, so just not because it won't, not because it can't, but just because we don't have those skills yet. Okay, so here we go. We're going to go straight into this time. I've got a couple of binomials here. We know how to get that into polynomial form. We're going to FOIL it, expand it, distribute it, whatever you usually call it. So 5 times 3 will be 15. Note that I'm not taking the derivative yet, so this is still y equals, okay? Then I go 5 times 2t, so plus 10t. Some of you will be able to do this in less steps, so minus 3t, and then minus 2t squared. Put all that together, I got y equals 15 plus 7t minus 2t squared. And at this point, it's polynomial, and I'm ready to take the derivative, okay? So the derivative of a constant, remember derivative of a constant is 0, so that's going to go away. Then I'm going to have y equals 7t, so the t, remember, has a 1, so bring the 1 times the 7 in front. I'm left with 7. The t goes from 1 to 0, so the t is going to go away. And then I've got minus 2t squared, so I'm going to multiply the 2. So that will give me minus 4t. And this is now, sorry, that's not y, that is dy dt. That's the third one. Let's do one more, and then, I might have one more. Just can't see it. Okay, so let's do the next one. Last one before we try something a little bit slightly different. Okay, we go y equals 3 times r plus 5 squared. Again, need it in that polynomial style format. I can't have these parentheses hanging out. We don't like parentheses or anything like that. So let's get rid of them. Remember, you can not distribute the squared. Do not. Just don't do it. It's not allowed. So we need to do something else. Remember, squared means multiplied by itself. So I'm going to go 3 times r plus 5 times r plus 5. And at this point, it's now y equals 3 times. I'm going to distribute those first. You can distribute in any order you want, right? It's multiplication. Multiplication can be done in any order. That's one of your properties of multiplication. When you have things multiplied together, you can do it in whatever order you want. So I'm going to choose to do that one first, just because I can. So r times r is r squared. I've got the r times 5 and that r times 5, which will give me 10r. And then I've got 5 times 5, which will give me a plus 25. At this point, I am going to distribute the 3. You technically don't have to, but I would, just so that it's in that polynomial format. So y equals 3r squared plus 30r plus 75. And at this point, you're ready to take the derivative. Before that, please don't take the derivative because we're not in the proper format, at least the one that we are comfortable with using at this point. Okay, so dy dx equals, bring the 2 in front, 2 times 3 is 6, times r, remember, subtract 1 from the exponent, that'll make it a 1. And then here, 30, I've got a 1 there, so bring the 1 in front, that'll leave me with plus 30. And then, of course, the derivative of a constant is 0, so it stays the same. So our answer right there, dy dx equals 6r plus 30. All right? Now, let's do one more to kind of wrap it up. Remember, the whole point of this, we were talking about the fact that the derivative gives us the gradient function, okay, which will allow us to find the slope at any point. So this is a type of question that they might ask. They may say, if y equals x squared minus 3x, find dy dx when x equals 4. Honestly, I don't give a dang why, but that's what they asked us to do anyway, so we're going to do it so we get the points. So here we go. First, we want to find the derivative function. So we're going to find dy dx. Okay. So dy dx, here's my function. So that's going to be straight up enough. Dy dx equals, bring the 2 in front. 2 minus 1 is 1, which will leave me the exponent of 1. And then, again, here the 1, bring it in front, minus 3. You're probably starting to find some patterns that will help you do this a little bit faster. Namely, anytime that there's an x, when you take the derivative, the x is just going to go away. Anytime it's a constant, it's 0. Those things you'll start to notice. You'll get a little bit faster and quicker at this. Okay, so here's my function. That's the derivative. Now, the question is, this gives me the gradient at any point on the function. okay? But it wants me specifically to have the derivative when x equals 4. So for that, I'm going to go ahead and put 4 into x. And so then I'm going to have dy dx, which is the gradient, equals 2 times 4 minus 3. 2 times 4 is 8, minus 3 is 5. So there we go. That is my slope. The answer to the question, find dy dx when x equals 4. dy dx, or the gradient, or the slope of the tangent, are all the same thing, 5. All right? So hopefully that was good to get you started. Now I'll try a couple more where they give you a little bit more words and you kind of have to figure out what's going on. Later.